You know, lightning in the sky, socks that get all stuck together in the dryer, even the very atoms that make you, well, you. What do all those things have in common? It's this incredible, invisible force that pretty much runs our world. And to get a handle on it, we're going to start with a super simple magic trick you can do, like right now, in your own home.
Come on, you've totally done this, right? You rub a balloon on your hair and then boom, it just sticks to the wall, like it's defying gravity. It absolutely feels like magic, but I promise you, it's pure physics. And by the time we're done here, you're gonna know exactly how that little trick works.
Okay, so to figure this out, we have to zoom in. I mean, way, way in. We're talking about going down to the subatomic level, into this secret world of tiny particles. And that's where we find the very first clue to our mystery, something called electric charge. So what even is electric charge? Well, the easiest way to think about it is like a tiny built-in magnet, right? You can't see magnetism, but you know it's a fundamental property that lets things attract or push away from each other. Electric charge it's just like that. It's this invisible quality that all matter has, and it's what gives particles the power to push and pull on each other. And here's the thing, this charge isn't just one thing. It actually comes in two distinct flavors, if you will, positive and negative. See, deep inside every single atom, you've got these tiny particles called protons, and they carry a positive charge. And then you have electrons orbiting them, and those carry a negative charge. These two opposing forces, they're the absolute key building blocks for everything else we're going to talk about. Okay, and this is a really, really important point. When we say an object, like say a wall or a balloon, is neutral, it does not mean it's empty of charge. Not at all. In fact, it's actually buzzing with trillions of positive protons and negative electrons. Neutral simply means they're in a perfect balance. For every positive charge, there's a negative one right there to cancel it out. It all adds up to zero. All right, so we've got these two types of charges, positive and negative. Simple enough. But how do they actually interact with each other? Well, it turns out they follow two very simple but incredibly powerful rules. You can think of these as the fundamental rules of the game for this whole shebang. Rule number one is super simple. Likes repel. If you bring two positive charges near each other, they will actively push each other apart. And you know what? The exact same thing happens with two negative charges. They don't want to be near each other. And then there's rule number two. And this is the one that makes everything so interesting. Opposites attract. You bring a positive charge and a negative charge together, and they'll pull towards one another. And this attraction, this is the basis for pretty much everything, from chemical bonds all the way to our balloon sticking on the wall. Okay, let's get back to our balloon and see how this all plays out. So your hair and the balloon, they both start out neutral, right? A perfect balance of charges. But when you rub them together, that friction gives some of the electrons in your hair just enough energy to literally jump ship and move over to the balloon. Now, the crucial thing to get here is that we didn't create any new charge. Nope, we just moved it around. Now the balloon has a bunch of extra negative electrons, and your hair is left with a deficit, making it positively charged. All right, so now we have our negatively charged balloon. And we know it can push and pull on other charges. But there's still a piece of the puzzle missing, isn't there? How does the balloon affect the wall from a distance? I mean, without ever actually touching it. Yeah, this is the big question, right? It's one thing for charges to interact when they're bumping right up against each other, but how does the balloon's charge kind of reach out across the empty air to affect the wall? The answer, my friends, is one of the most important and mind-blowing concepts in all of physics. And the answer is the electric field. Get this. Every single charge in the entire universe creates this invisible field of influence that just extends outwards from it in all directions. You can think of it like an invisible instruction manual that's filling all the space around that charge. So when another charge happens to wander into this field, the field itself tells it which way to move. Either get out of here or come on over. And here's how those instructions actually work. The field from a positive charge radiates outward, kind of like rays from the sun. And it's basically shouting at any other positive charges, go away. But the field from a negative charge, that points inward, and it's telling all the positive charges, hey, come on over here. It's this invisible field that's bridging the gap between objects that aren't even touching. So there we have it. We have all the pieces of the puzzle now. We've got our charged balloon, we understand the rules of attraction and repulsion, and now we have this amazing invisible electric field that carries the force. I think it's time we put it all together and finally solve the mystery of the sticking balloon. Okay, so here's the grand finale.
As that negatively charged balloon gets close to the neutral wall, its electric field reaches out and actually penetrates the surface of the wall. Now, this powerful negative field pushes the wall's own electrons, which can move around a little bit, just a tiny bit deeper into the wall, away from the surface. What does that do? It leaves the very surface of the wall with a slight temporary positive charge. And now what do you have? You have a negative balloon right next to a positive surface. And we know what happens then. Opposites attract. The force is just strong enough to hold that balloon right there against gravity. And there you have it. Magic explained.
But here's the most amazing part. This isn't just some silly party trick. The exact same force, this electrostatic force we just used to stick a balloon to a wall, is fundamentally the same force that binds electrons to their atoms. It's what holds molecules together. It is, and I mean is quite literally, the glue that builds our entire universe from the ground up. So from now on, the next time you see static cling in your laundry, or you get that little zap from a doorknob, you'll know exactly what's going on. And that kind of leaves us with a final thought, doesn't it? If this invisible force is powerful enough to do all of this, what other phenomena in our daily lives is it responsible for? Things happening right in front of our eyes that maybe we just don't even notice.